Hello everyone, so today we'll be making this simple Pong game using Godot engine 4.3 version. So let's get started. So first of all, we open the Godot engine and we make a project for our Pong game. And let me create the project. So after we create a project, we start by making a ball. So a ball that will follow physics. For it, we create a folder for the ball, and we create a scene. Scenes are Godot's way of making the game elements. So first of all, we change its type to a rigid body 2D instead of node 2D. So it will inherit all the rigid body physics properties. Also, we have to create a sprite 2D node to visualize the ball as an image, but we don't have an image, so we should create one. So I'm using an online tool called Piskel to create a sprite for us. Um, it will be a simple circle of orange color, and we'll soon be exporting it to the Godot engine. I'm trying my best to make it look like a table tennis ball. So we uh, copy the copy the ball sprite to the Godot project folder. We rename it to something you like. I like ball. So now it is imported in Godot, and we just have to drag and drop it to the texture property of sprite 2D. So we can see there is a ball, but it is too blurry, so we change the filter to the nearest bitmap so it looks pixelated. Also, make sure to add the collision shape to define the boundaries of our rigid body that we've created and the radius. So that's all. Now yes, we should make the gravity scale to 0 so it doesn't fall downwards, so it stays in the space. Also, to give the logic to the ball, we have to create a script. So let's create the script and remove all the older code, and we are actually interested in giving the ball some speed, and we want to make sure that ball stays in motion when we are playing the game. So that's why we are giving it some speed, and the minimum speed is actually used to make sure the ball remains more than the minimum speed, so it doesn't get uh, too much damped, because in physics we are actually constantly losing energy, so it will eventually be lowering the speed of the ball. So in the ready method, which called when the object is created, uh, we give the initial push to the ball using the function apply central impulse. It will give an initial push to the ball towards the left side, because we are passing the minus x coordinate to minus speed and the y coordinate to 0. So let's create a level script to test our uh, newly created ball. It's just a dummy level for now, but we'll actually later convert it into a full level. So we are going to instantiate the ball scene that we created earlier. So here is our ball, and we also have to create a camera to visualize the ball, and of course set the zoom to some appropriate level, and also make sure to uh, yes, let's test it. Yes, the ball is moving, but it is crossing the boundaries of the scene. So we have to make an obstacle, a static body, to stop the ball from going outside the screen just for testing, because we want to test whether a ball will bounce or not. So let's test it. So I created a rigid body to block the ball. Yes, it doesn't bounce. So we have to go back to the ball, and yes, we have to create a physics material, and we have to set the bounce value to 1. 1 is the maximum bounciness, it means the ball will bounce fully, and 0 means no bounciness. Now let's test it. Yes, it is bouncing exactly. This is what we need. So our ball component is completed. One more thing, we have to make sure the ball does not lose energy when colliding too many times with different objects. So we replicate our static body and we test it to make sure the ball doesn't lose any energy, but it actually does slow down after some time. So in the ball script, we go back and we uh, make sure a signal is connected to detect collision. Whenever a body is entered, then this function will be called, and whenever a body is entered, we want to make sure that the ball will gain some energy instead of losing. So we have to artificially give it a push after every collision. So in this function, we check when the magnitude of linear velocity is less than our minimum speed that we defined earlier. So just give it some push in its own direction, in the direction in which it is already going. Otherwise, just do nothing. So this will keep the ball in motion no matter what. Whenever it will have its speed less than the minimum speed, we will just give it an artificial push after the collision. And of course, it is about the collision with the pedals that we are going to make in the future, but now for testing, we'll be testing them on our dummy level. So let's test it again. uh, mm, no, no, yes, it is not actually detecting the collision because we haven't enabled uh, the contact monitor, which was required by the rigid body. It is not required by the character body or others, but it is necessary for the rigid body, and we have to make sure the contact monitor is set to some greater value. Now notice, yes, the speed suddenly increases. This is what we are looking for. Now the part 2 is to make the pedal. Remember, we are just going to replace those static bodies with the actual pedals that move. So for pedal, we make another folder, and in this folder we make the scene just like we did for the ball, and we'll call it pedal. We'll change its type to character body instead of rigid body, because we are going to control it by ourselves by the user input. So we change it to character body, and we also give it a polygon. Polygon is just a way to make some simple shapes directly in the Godot editor instead of making it on the outside image editor. So we are just going to plot some points. We are just going to arrange these points appropriately so it looks like a rectangle, like the Pong racket or whatever we call it. So um, yes, it looks perfect. We just have to make it centered a bit. Yes. So after it, we have to create a collision shape for this one as well. So let's create a collision shape. So now we have to create a script for this one as well, where we will put the logic of the movement up and down. So just remove the older code that is already generated. So first of all, we also define its speed, the speed of the pedal moving up or down. so it will be like something. So after this, we make sure we define the players, because there will be two players, player 1 and player 2. So we use an enum to define two players, player 1 and player 2, and the variable below will actually store one of those values. So when we instantiate this scene, uh, we will assign two different values for both the players. One player will get the value of player 1, and the other will get the value of player 2 when in the level. So in the process is the function that continuously gets called every frame. Physics process and process are kind of same, but so in this we check if the player is player 1, then make move for the player 1, and if the player is player 2, then make moves for the player 2. The logic is same, the only difference is that they will use different keys for their inputs. In our example, one of them will use the arrow keys, and the other one will use either keys. Like for example, I use home and end key, you can use WSAD, whatever. So currently we just make the functions as empty, just to eliminate the error. So now we'll do the check. If input dot is action pressed whenever input key is pressed, so do what? Just increase the velocity. For now, just pass the UI up, it means the up arrow key. So we'll just increase the y component of velocity. Basically in Godot we actually decrease it, because in Godot the y component points downwards, so that's why. So when we decrease, it means we are going up. So so we do the opposite for the down key. Make it minus instead of plus, like this. So and we then literally just copy the same logic and put it on the function for the second player, but we just change the input keys. Instead of UI up, UI down, we use other set of keys like UI home and UI end. You can use any keys of your choice. After this, make sure to call move and slide a function to make sure our velocity is actually used to move the character body. So now just we can instantiate this in the level scene. I think yes, in the level scene we can remove the older static bodies, and we can just instantiate the new pedals. Pedal, move it to the left and then copy it by pressing shift D, or you can just duplicate it using the drop down menu and move it to the other side. And yes, there's one thing that we did not define. Make sure to define the player variable as an export variable, so it appears on the editor like this. Now you can see that it is appearing on the editor on the right side. So for one player we make it player 1, for the other we make it player 2. For this one it's player 1, fine, and for the other one we just make it player 2. So now they both will behave based on different set of inputs. Now let's test it. So yes, oh, what the we actually have to make sure the speed is not too much. It's fine enough. So again, let's test it. Change the speed again. Yes, it's kind of fine, but we see that our Pedals are also moving in response to the collision, and this should not occur. So maybe using move and slide will help. Let's test it. Yes. No, no, no. It is still moving the pedals in the opposite direction. So let's test it. But the problem is still there. We just fix the speed, because when using move and collide our speed changes for some reason. For the purpose of testing, we are going to make a boundary against the screen ends, so we do not let the ball get out of the screen. It's just for testing, for temporary testing. So let's do it. Yes, they are working fine, but the problem is that the pedal also moves in the opposite direction, and this should not occur. So for this we use I think, yes, we should make another variable to store the initial position of the pedal. So every frame we just override that position again, so the x position does not change no matter what happens, because we are concerned with x position only. The y one should change. So in the ready, I mean, whenever the node enters the tree, we just assign its position, and then we make sure that it stays in that position and it doesn't move forward or backwards. And here we just assign the position. We make sure the x position of the pedal remains the same as its initial x position. So now it should not move backward or forward, because it will reset every frame. Yes, exactly. This is just a small, a spring like motion, but it's fine. Yes, exactly. This is what we need. So we low-key already make a Pong game, but see this thing that is occurring. The ball is moving up and down. We can prevent it by just simply removing the static bodies that we made earlier. So now let's go and make the level properly. First of all, remove the static bodies and make sure to make an area. We want to make the goals for the two players. For the player 1, the goal will be on the player 2 side, and for the player 2, the goal will be on the player 1 side. So make area 2D nodes and also attach collision shapes to them. Area 2D is a way to detect, for example, if something comes in that area, so it will detect. So whenever a ball will enter the area, I mean the collision shape of the area, it will immediately detect that something has entered. So we make the player 1 goal, and we give it a we just line it on the opposite side of the player 1. And yes, it's fine. uh, let's change its color to some different color. I don't like the blue color, just it's fine. The red one is fine. So for the opposite player, we just replicate it, and by pressing shift D, and we move it to the opposite direction, like this. Just change its color to some other color. This one, no, this one. Yes, it's fine. So now how will this area detect that ball has entered? For this, we have to attach the signals that I'm going to attach after some time. Let's add some boundaries, up and down boundaries. First we make boundaries. Boundaries are also areas that will detect whenever the ball hits them. So when the ball hits them, we just respawn the ball again, because currently if the ball exits the screen, it will just continuously keep moving. So we make a boundary and we make sure the ball does not, make sure the ball stays in the place. So let's do this. Yes, we also have to attach a script to the level so we can actually spawn and despawn the ball. So first of all, make reference to the ball scene. uh, we just preload the ball uh, before before the game, before the level actually starts, and we in the ready we just spawn the ball. I mean, we just instantiate the ball and we spawn it on the center of the screen, and the ball itself will automatically move towards the left as we defined earlier in the ball script. mm, this is the current ball, and whenever the ball leaves the boundary, we just despawn it, makes the ball null again, and then we just respawn it again, and the cycle will go on like this. We just spawn the ball, we set the position to the center of the screen. mm, and we the center of screen is just the size of the viewport divided by 2. uh, yes, we, as I earlier said, we have to attach the signals. So whenever a ball hits the goals, we get the signal, we get this function called, so we can increase the score and do whatever we want. And for the boundary, we can just despawn the ball whenever it hits the boundary. So for now, just add variables for the scores: player 1 score and player 2 scores. mm, like this. And we just increase the player 1 score whenever it hits the player 1's goal boundary, and we increase the other player's score whenever it hits the other player's goal. And for the boundary, we just free the memory of the ball, we just delete the ball, in short, from the scene, and we make the ball null. And we also make another function, the process function, that gets called every frame, and we check that whenever a ball is null, we just make the ball again using the same logic we used in the ready function. Just copy and paste it there, like this. So, and make sure to delete the ball from the old one that we hard coded in the scene tree, so that the code create the ball for us. Now just test it. No, we don't see any ball. The ball was not added to the scene tree. So first of all, I thought this one might be the issue, but yes, of course, this one also was the issue, but the other issue was that the ball was not made the part of the scene tree itself. See, it will still not work. Um, mm, See, it will still not work. So I just remembered that I did not call the add child function, which was necessary to add the node to the scene tree. otherwise it won't be visualized, it will just remain in the memory. So yes, now it will work. Let's see. Yes, it's working. So we just made some sort of Pong game, and our score is also increasing or decreasing, but we cannot visualize it because there is no label, nothing else to visualize. So we should first of all, I'm going to make the boundary a bit distant from the edges of the screen so the ball doesn't instantly get despawned. It just keeps traveling, and after some time it then get despawned. So the user will have some time to wait before the ball spawns again. So it will help slightly. For example, like this. It will, it still is pretty fast. We can make it even more further, but just fine. We can do it later. So we have to create. There was one thing that I noticed, that the pedals are going out of the screen. So one of the hacky way I used was just to place the static body on top of pedals, both pedals, top and bottom of both pedals, so they don't move move outside the screen bounds. This is, I think, the most hackiest way and not a very good way to do it. Like this. We just copy it on for the other side as well. So let's test it, and we will see that the pedal is not going outside the boundaries of the screen like this. So what the glitch? I don't know what happened. I think that maybe I could have placed the line on the wrong position, but I'm pretty confident I placed it in the right position. But still, maybe putting it on the top of the frame as well will help. Maybe, I don't know, but just to make sure. How can I test it again? So I think we should proceed with the UI now. So we make the nodes. Labels. Labels are just text that are displayed on the canvas. We name it the player 1 score, and we name the other one the player 2 score by just duplicating it, and we just position them on the screen. Again, this is not the good way to position by just dragging and dropping. We can use the layouts, but for this tutorial I'm just doing it the most hackiest way possible, just to make it work quickly. So we have to create the references for our labels as well, so we can update the label text on the runtime with the fresh scores that we get from the player whenever the score changes. So we make two variables for the labels, and we update their text whenever the score changes. So um, So we just update its text to be the player one score, and we do same for the other one as well. So now whenever the score changes, we get the we can just see it in the label. So let's see that like this. See, the score is increased for the other player and increased for this one as well, so it's working. So we can add some styling as well. It's a very basic styling, but we can just make it as a color rect, just add some color to the background, and we can change the color to some other value, like I think this one, maybe. Yes, this one is fine. And we can add some other styling as well, like line on the center. So it's too thick, actually it's too thick, so we have to make it a bit thinner, um, like this. Maybe this is fine, and we just do it same for the other side as well. And we can change its color to some less intense color, not so white, like this, like I think this one, a bit this one, yes, this. So it low-key looks like a Pong now. So let's play it. Yes, it's actually working, but we can still add some more styling. Like we can change the colors of the pedals, so they are not white. One of them should be the different color. So let's check that. If it is player 1, then just set its color to something, and then if it's player 2, then set its color to some other color. So let's do it. Yes, so it's kind of fine, but I think the colors are a bit dull, but we can fix them later. So it is working now. Yes, we can actually change the font of the labels, because the current font is too boring, so we can just uh, use some pixelated font, maybe. uh, mm, Maybe this one. Yes, you can just download it and copy it there. Yes, exactly. And to use the fonts, we just have to drag and drop them on the theme overrides, and in the font section we just have to drag and drop the font to the font section. Yes, like this, and we just get the font. We do the same for the other node as well. So yes, so we get the correct fonts. Now the game looks a bit like a game. We just The final thing you can just do is to just change the colors. Yes, it looks good. Just change the color to some more bright colors, red maybe, or maybe some, maybe yes, yellow. Now they now the last step is to make a main menu, so it looks like a game. So for this, again, make a folder for the menu, make a scene, and in that scene we'll be making two buttons for the play and for the exit, and a title. So there are several steps. I got stuck myself, so I just kept experimenting with several different approaches until I got it right. So let's see. So I finally managed to make it centered. So the title is just a label with the same theme that we applied earlier, and we just increase its size to some bigger number, like this one maybe. Yes. And now below it we just create two buttons, one for the play button and one for the exit. We just change the text to start, and we just duplicate the button. mm, we just duplicate it and we just rename it to uh, exit or something, and we change the text as well. After that we add a script to the scene so we can define the logic. So whenever the user presses the start button, just go to the game scene, I mean the level scene, and when the user presses the other button, we go to user presses the exit button, we just exit the game. But before that we make the background just for the final touch, like this one. Yes, it's look pretty good. And mm, we we add a script, and in this script we just connect the button pressed signals. So whenever the button will be pressed, we just get the function called. So whenever the start button is pressed, we just redirect to the level scene. It is a very simple function that Godot provides. Change scene to file, we change it to the level scene, and for the other part we just get tree.exit, I'm sorry, get tree.quit, and we pass the success code. So now it is kind of completed, and we can just test it and play it. No, we actually have to make sure the Godot actually runs the main menu instead of the level scene when we first start the game. So like this. So that's all. Thank you for watching, and make sure to, if you like my videos, make sure to you can subscribe it, and you can also view it on my website.